So same thing, they're still asking us about one-to-oneness. So they're saying, is that function? Now they're doing it not with an arrow diagram, but with like x, y. But you know the deal, right? It's just x, y, x, y, x, y, x, y. So if it helps you, you can make like an x, y arrow diagram. You don't have to by any means. 4 goes to 9. That's what x, y, 4, 9 means. 3 goes to 6. That's what x, y, 3, 6 means. Negative 8 goes to 3. That's what x, y, negative 8, 3 means. And 1 goes to negative 8. X, y. That's what they mean. So anyway, you could just look at this if you want or do that if you want. Is it one-to-one?
Yes.
Yeah. Yes, it is. So there's no doubling up, right? Never does one thing go to 2 or 2 to 1. It's 1 with 1. 1x with 1y. Some of this one-to-one thing, and they're going to say, okay, is this graph one-to-one? Yeah, basically, to be one-to-one graph, you got to pass the vertical and the horizontal. I know they're only mentioning the horizontal because they're assuming it already passed the vertical, which it did. Let me mention it, though. You know if you have a function that looks, say, like this. That's not a function, really. This one would be not a function because it fails the vertical line test, right? Because a vertical line hits in 2 points. So if you ever have a vertical line that hits in 2 points, that's not a function, okay? So first off, you just got to be a function. Now, what if I gave you one that looks like this? You know, that'd be y equals x squared, right? This passes the vertical test, right? What do I mean it passes the vertical test? I mean every vertical line only hits 1 point, not 2. So it passes the vertical, but it fails the horizontal test because there's horizontal lines that hit 2 points, huh? What does that mean? So it's a function, yes, but not one-to-one. So it's the second higher standard. So best kind of function is the one-to-one. So there's first off just being a function, and then there's the best kind of functions, the most useful, the easiest to manipulate, are the one-to-one functions. So y equals x squared would be a function, but not a one-to-one function because it fails the horizontal line test. You can tell some points that would not work. Can you guys give me some points? What would be a couple of ordered points in which you see it's not 1x for 1y? Say you can square the x. What could you do with the x? 2 different x's go into the same y. Yeah, 1 and negative 1 would both go to y value 1, right? x1 goes with y1, and x negative 1 squared also goes with y1, right? Negative 1 or positive 1 squared for x leads to y positive 1. See how it's not 1-to-1? Those are 2 x's going to the same y. So that's why it's not. X squared is not a 1-to-1. It fails the horizontal line test. Right there. Fails it. So anyway, what about our question? Does that thing pass? Yeah, that's a no-brainer. Right? It passes the horizontal. Every horizontal line only hits 1 point. So ours is a yes. It passes the horizontal line test. Okay. Why do we care? I mean, who cares? Why do we like one-to-one functions? Well, basically, remember again, something's only a function if it passes the vertical, right? Well, then, vice versa, when you do an inverse function, which means you invert things and you switch roles on everything, and x's become y's, and y's become x's, and domains become ranges, and vertical line tests become horizontal line tests, right? So basically, if some function like x squared is a function but doesn't pass the horizontal, then when you invert it, the new thing won't pass the vertical. Won't be a function. There will be no inverse function. There'll be an inverse, but that inverse won't be a function. You see the deal? That's why we're obsessed with one-to-one. That's why we like one-to-one functions best, because you can invert them and you still got a function. Otherwise, if you start with something like x squared that fails the horizontal line test, when you invert it, the new thing's going to fail the vertical line test and won't be a function. The inverse will not be a function. That's why we like one-to-one functions. They're invertible. Other ones are not. All right. 3 seconds. That one passed the horizontal line test. Quite no, right? Lots of horizontal lines hitting 2 points. So not 1 to 1. It fails the horizontal, which means it's not one thing for one thing, right? Because whatever this y value here, what is this, up 3? Right? You can tell, when you fail the horizontal line test, it looks like this is the point, like, what, over a half up 3 and back a half up 3. Whatever, they're both up 3, aren't they? They're both at the same horizontal level. And they're different x values, so it's not 1 to 1. When you fail the horizontal line test, you're not 1 to 1. So it's not 1 to 1, which means it's not going to have an inverse. It's not going to have an inverse. Does that make sense? So let me make sure I'm getting through to you. Why do we care about the horizontal line test?
It shows it's a 1-to-1 function.
Shows it's a 1-to-1 function. And why do we care about that? Because then you can invert it, right? So anything that fails the horizontal line test does not have an inverse, right? Now, having said that, you've all been through trig. Trig was a prerequisite for this class, right? Remember talking about sine inverse? Cosine inverse? Well, we're not doing that right now, but we will in a month or two. We're doing the trig at the end of the course. We'll review trig again, which is good right before you go to calc, especially calc 2. Especially calc 2. I warned my sweet little daughter. She's in calc 2 right now, and I told her, I said, calc 2's the trig one. And sure enough, calc 1's got a little trig. Calc 2's got a ton of trig. And she was saying to me, she's like, this is too much trig. I don't remember all this trig. So you got to remember your trig for calc 2. Anyway, so remember inverse sine and cosine? Right? Inverse sine and cosine. What's the graph of regular sine look like? Kind of starts here and, that kind of thing, right? Right? How's that thing do on the horizontal line test? Fails it miserably. Bang, 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 bang. Horizontal line hits in infinite points. So it fails the horizontal line test. So what does that mean when you fail the horizontal line test? You're not 1 to 1, and you don't have an inverse. Wait, hold on. You studied sine inverse, didn't you? What is going on? I don't know if all these facts were bubbling around in your mind when I mentioned 1 to 1. If you're not 1 to 1, you don't have an inverse. Did anybody already think, well, what about sine? He's not 1 to 1. He fails the horizontal line test, yet I remember doing the inverse. Cosine, same thing. What's the story with that? Yeah, I know. I'm not surprised. I know this is one of the very subtle points. We don't really invert the whole sign. We only invert a restricted sign. We just take a small piece of sign. That's all we're inverting, not the whole sign. That's why you got to worry about all those restrictions for inverse functions, because you're not really inverting the whole thing. You're only inverting a small piece from -pi/2 to pi/2. Anyway, that's later. I don't got time for messing around with that now.